Alright, continuing to examine what the effect of feedback is on input and output impedance, we're now going to see what happens with a shunt connection. So let's take as an example the series shunt feedback that we were just looking at, and we'll look at the shunt port at the output of the amplifier. So we'll draw the circuit really quickly. Alright, we have a shunt connection, so we'll make sure that we show the shunt connection. And we'll connect our series connection at the input. Alright, so what we want to do here now to find the output impedance is to place a test voltage source across the output, Vx, and measure the current, Ix, that flows from that voltage source. Alright, and actually what we're going to do is find the conductance, because it's easier to find conductances when we're looking at shunt circuitry. So we're going to find YO is equal to Ix over Vx, and note that the inverse of that is equal to the output resistance. Alright, so when we find conductances, we need to make the voltage at the opposite port equal to 0, and so we're going to short circuit the opposite port that we're looking at to find that conductance. And what we would note then is that VE plus V beta is equal to 0, just doing KVL around the input loop. We know that V beta is equal to beta times V out, so we can say that VE is equal to minus beta times V out. Alright, looking at the output, we can say that Ix is equal to Vx minus AV times VE divided by ROA, just using Ohm's law at the output. Making substitutions, we can say that this is equal to Vx plus AV times beta times Vx divided by ROA. And if we solve for resistance at this point, Vx over Ix, we have Vx over Ix is equal to ROA divided by 1 plus AV times beta. Or we can say ROA divided by 1 plus the loop gain. Now what we see with a shunt connection here is what we'll see with all shunt connections. Shunt connections in feedback reduce impedances by a factor of 1 over 1 plus the loop gain. So if we want to figure out what happens to the impedance of a circuit, we can find the forward resistance first, and then divide, if we know that we have a shunt connection, divide that resistance by 1 plus the loop gain. Now in this case what we see is we wanted a voltage output, and we know that for a voltage output we'd like to have a smaller impedance at the output, and so this reduction in output resistance helps us and makes our voltage output better.